Hello students, welcome to AIMS India online classes. Here we are discussing about the chapter atoms and molecules. In this session, we are going to see about types of chemical reactions. In this part 2, that means in the earlier session, we have seen certain kinds of chemical reactions like chemical combination reactions, chemical decomposition reactions we have seen in the earlier session. Now we are going to see the remaining types of chemical reactions here. So let us see first about displacement reactions. The reactions in which one element takes the place of another element in a compound are known as chemical displacement reactions. Or to say simply, the chemical reactions in which an element displaces another element from its compound to form a new substance is called chemical displacement reaction. See here some examples shown diagrammatically. Initially there is a substance or compound formed by A and B elements. This on reaction with element C, here the element C is being more reactive than element A. It is replacing element A from its compound. So element A is emitted out. Now it is forming a compound BC. So in this reaction, element C replacing element A from its compound and forming a new compound. This kind of reactions in which a more reactive element displaces less reactive element from its compound is called chemical displacement reaction. In general, more reactive element displaces a less reactive element from its compound. For example, let us see some examples on this. Displacement of hydrogen from acids by metals. Generally, metals which are more reactive than hydrogen displace it from acid. Acids contain hydrogen. So when these acids react with metals, metals are being more reactive than hydrogen. They displace hydrogens from their acids and they form respective salts. Let us example here. If dilute hydrochloric acid is added slowly to a small quantity of zinc dust taken in a conical flask, zinc pieces react with dilute hydrochloric acid and liberate hydrogen gas. So what's happening here? Zinc reacting with dilute hydrochloric acid. So in the hydrochloric acid there is a hydrogen. And here zinc as being more reactive than hydrogen, it reacts with the hydrochloric acid and replaces that hydrogen from acid and forms zinc salt. So this can be observed. Actually, we are telling zinc replaces hydrogen and forms zinc salt. So hydrogen gas is liberated. This liberation or evolution of hydrogen gas can be observed by tying a balloon to the conical flask. The balloon bulges out as gas bubbles coming out from the solution. This proves that hydrogen gas evolution. So zinc reacts with hydrochloric acid and forms zinc salt by replacing hydrogen from the acid. So hydrogen gas is evolved out. That is collected in this balloon. So this is a reaction occurring in this reaction, in this displacement reaction. Zinc reacting with hydrochloric acid. So hydrogen is being less reactive than hydrogen. It is replaced by zinc. So zinc chloride is formed and hydrogen gas is evolved out in the form of gaseous form. So in the above reaction, the element zinc has displaced hydrogen from hydrochloric acid. This is a displacement reaction. Okay. Let us see another example. Displacement of metal by another metal. Earlier we have seen displacement of hydrogen by metals in the acids. Here, metals also can replace less reactive metals. Let us see an example. If an iron nail is dipped in about 10 ml of copper sulphate solution taken in a test tube, and if it is kept undisturbed for a few minutes, around 20 minutes, the iron nail becomes brown. See, initially iron nails will be gray color or light, we can say light green color. and the color of copper sulfate solution is blue. When you dip an iron nail into this copper sulfate solution and if you leave it for few minutes, then you can observe the iron nail becomes brown. Observe here, what is the color of the iron nail? It became brown, isn't it? Yes, and even observe the color of the solution also. Initially, the copper sulfate solution is in blue color. When iron nail is dipped into that, the color of the solution faded. It becomes colorless and it becomes light green in color. The chemical reaction, this activity is actually iron on reaction with copper sulfate forms iron sulfate and copper. Here, iron is being more reactive than copper in the copper sulfate. It displaces copper from its compound and forms iron sulfate. Copper is omitted out. So here, iron displacing copper from its compound and forming a new compound, iron sulfate. That is why this is called displacement reaction. Metal displacing metal. Iron is being more reactive than copper, so it displaces copper from copper sulfate. So this is another example for displacement reaction in which a metal is displaced from its solution by another metal. Okay. Let us see some other examples for displacement reactions like zinc reacting with silver nitrate forming zinc nitrate and silver. Here, which is more reactive metal? Zinc is more reactive metal than silver. So it is replacing silver from its compound forming zinc nitrate. Silver is omitted out. Let us see another example. Lead on reaction with copper chloride forming lead chloride plus copper. Here, lead is being more reactive than copper. It is replacing copper from its compound. Okay, these are examples for displacement reactions. Next, another type of chemical reactions, double displacement reactions or double decomposition reactions. The chemical reactions in which two compounds react by an exchange of ions to form two new compounds are called double displacement reactions or double decomposition reactions. See here example diagrammatically shown, a compound AB combining with another compound CD. Here these two ions are exchanged between these two compounds. So D is coming and combining with A and B is coming and combining with C, so that two new compounds are formed. This we can say the chemical reaction in which two compounds exchange the radicals mutually to form two new compounds are called chemical displacement reactions. For example, if lead nitrate solution is mixed with potassium iodide solution, yellow colored substance which is insoluble in water is formed as precipitate. So the precipitate formed is lead iodide. So what we have taken initially, lead nitrate solution and potassium iodide solution. Both are colorless solutions are taken. When these two are mixed, immediately an yellow colored substance which is insoluble into water is formed as precipitate. So this precipitate formed is a lead iodide. So this lead iodide is formed by the mutual exchange of ions between lead nitrate and potassium iodide. So we can say this is a double displacement reaction. See the equation regarding this chemical reaction. Lead nitrate on reaction with potassium iodide, lead iodide and potassium nitrate are formed. So this iodine ion coming and combining with lead, this nitrate ion coming and combining with this potassium. So they form lead iodide, potassium nitrate. In this way, these two compounds are exchanging the radicals mutually to form two new compounds. Hence it is called double displacement reaction or double decomposition reaction also. Okay. Some other examples for double displacement reactions are shown here. See, sodium sulfate solution on mixing with barium chloride solution forms a white precipitate of barium sulfate and soluble sodium chloride is also formed. Now these two are aqueous solutions. which are soluble into water. So when these two substances are mixed, they form a white insoluble solid substance called barium sulfate. So here what happened? The sulfate combining with barium forming barium sulfate. This chlorine combining with sodium forming sodium chloride. What's happening here? Mutual exchange between the molecules is happening. So you can say this is double displacement reaction. Let us see one more example. Sodium hydroxide reacts with hydrochloric acid to form sodium chloride and water. See the equation, sodium hydroxide and hydrochloric acid. We can say this also as a neutralization reaction, isn't it? Because here a base and an acid are reacting together to form a salt and water. So we can say this as neutralization reaction also. What's happening here? This chlorine combining with sodium to form sodium chloride. This hydroxide ion combining with hydrogen to form water. Mutual exchange of ions is occurring between these two molecules. So it is a double displacement reaction or double decomposition reaction. Next, another kind of chemical reactions is oxidation reduction reactions. The chemical reactions in which one reactant gets oxidized and the other reactant gets reduced are called oxidation reduction reactions, or simply called redox reactions. That is, in the chemical reactions in which oxidation and reduction occur simultaneously are called redox reactions or oxidation reduction reactions. So here what is meant by oxidation reduction? Oxidation is a chemical reaction that involves the addition of oxygen or removal of hydrogen to a chemical substance. The chemical reaction in which a chemical substance gains oxygens or loses hydrogens is called oxidation reaction. In the reverse way, reduction reaction is a chemical reaction that involves the addition of hydrogen or removal of oxygen. That means the chemical reaction in which a substance gains hydrogens or loses oxygens is called reduction reaction. If these two reactions occur in a chemical reaction simultaneously, then that is called redox reaction. Let us see an example here. When small amount of copper powder is taken in a china dish, is heated with a Bunsen burner or with a spirit lamp, then copper combines with atmospheric oxygen and forms a black colored copper oxide. What's happening here? Some amount of copper oxide is copper powder. Brown colored copper powder is taken in a china dish and it is heated on the spirit lamp or Bunsen burner. Then what happens? This copper on heating combines with the oxygen present in the atmospheric air and forms a black colored copper oxide. Okay, let us see the equation related to this. Equation or the chemical reaction occurring here is copper combines with oxygen and forms copper oxide. So here copper is combining with oxygen to form copper oxide. That means oxygen is gained by copper. Means copper gaining oxygen, and hence the process is called oxidation. Okay, oxidation means gaining of oxygen. Here copper gaining oxygen and converting into copper oxide. So this reaction is said to be oxidation reaction. Now if hydrogen gas is passed over this hot copper oxide obtained, so what happened? When copper is heated in the presence of air, it converted into copper oxide, black colored copper oxide. If onto this copper oxide hydrogen gas if it is passed, then this black colored copper oxide converts into copper again. This converts into brown colored copper. That means copper oxide losing oxygens and forming copper. This is the equation occurring here. Copper oxide on reacting with the hydrogen at this high temperature converting into copper and water vapor is evolved out. So what happened here? In this process, oxygen is lost by the copper oxide and forming copper. So the loss of oxygens is called reduction. In the earlier process, what happened? Copper gained oxygen. That process is called oxidation. In this process, copper oxide lost oxygens. So it is called reduction reaction. So generally, oxidation reduction occur in the same reaction. If one reactant gets oxidized, the other gets reduced. Such reactions are called oxidation reduction reactions, or also called redox reactions. In the above reaction, copper oxide copper oxide hydrogen reaction, copper oxide is reduced and hydrogen is oxidized. Yes, in the same reaction, if you see copper oxide and hydrogen they combine, what happened finally? Copper oxide converted into copper, and this oxygen combined with hydrogen. So hydrogen gaining oxygen. Now we can say hydrogen is oxidized, copper oxide is reduced. Both occurred in the same reaction, isn't it? Yes, then that reaction is said to be redox reaction. See here, when copper oxide is heated in the presence of hydrogen, copper oxide converted into copper. At the same time, hydrogen converted into water. Means this lost oxygens, so it is undergone reduction. We can say copper oxide is reduced. And this gained oxygens, so we can say this is oxidized. Both reactions are occurring simultaneously in the same reaction. So we can say this is redox reaction. Let us see some other examples for redox reactions here. Iron oxide on reaction with copper forming iron carbon dioxide. So this is an example for redox reaction because here iron oxide losing oxygens. So it undergone reduction. And carbon it gained oxygens. So it undergone oxidation. So it is a redox reaction. Another example, lead oxide on reaction with carbon forming lead and carbon dioxide. Here also lead oxide losing oxygens on reaction with carbon. So it is undergone reduction. Copper gained oxygen to form carbon dioxide. So we can say this is oxidation reaction. So as both reduction and oxidation occurring in the same reaction, this reaction is said to be redox reaction or oxidation reduction reaction. Okay. Now let us see another type of reaction, corrosion. It is also one of the forms of oxidation. When some metals are exposed to moisture or acids, they tarnish due to the formation of respective metal oxides on their surface. This process is called corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, etc., and to all other objects that are made up of metals. Isn't it? We will be observing corrosion of metals often in our surroundings. Some iron objects, if they are kept outside in the air, after few days, if you observe, there will be brown colored moss formed on these iron articles. That is rust or corrosion. This happened because these metals react with atmospheric oxygen in the presence of moisture, so they form rust. This formation is called corrosion. So this corrosion is especially causes damage actually, especially corrosion of iron is a serious problem because most of the materials around us are made up of this iron. So if this iron is getting corrosion, that spoils the objects. This spoils the quality of those iron objects. So it is a serious problem. This corrosion can be prevented or at least minimized by shielding the metal surface from the oxygen and moisture. Yes, we are telling this corrosion is formed due to the reaction of metal with atmospheric oxygen and moisture. So if we avoid these two, oxygen and moisture, and coming in contact with the metals, so that corrosion can be prevented, at least it can be minimized. So this shielding of metals from these oxygen and moisture will be done in several ways. It can be prevented by painting, oiling, greasing, galvanizing. even with the chromium plating or making alloys also. By these all processes, metals can be prevented from getting corrosion. Galvanizing is a method of protecting iron from rusting by coating them with a thin layer of zinc. Yes, the coating of iron particles with a thin layer of zinc is called galvanizing. So by this galvanizing process, iron particles can be protected from getting corrosion. Alloying is also a very good method of improving properties of metal. Yes, alloying is also one of the best methods in preventing corrosion. Not only in that, in improving the properties of metal. Generally, pure form of iron is very soft and stretches easily when hot, and even it gets corroded very easily. When iron is mixed with carbon, nickel, and chromium to get an alloy called stainless steel, that stainless steel is hard and does not get rust or corrosion. Okay, so by this alloying also helps the metals to get protected from the rusting or corrosion. For example, iron, if you take pure iron, it is actually soft and it can be stretched very easily, and it reacts with atmospheric oxygen very easily and will be corroded. But when this iron is mixed with some materials like carbon, nickel, chromium, it forms a material called stainless steel. Stainless means corrosionless. Stainless steel is formed. This stainless steel is very hard than iron and it won't get rust. Okay, in this way, alloying helps metals to get protected from rusting. A metallic substance made by mixing and fusing two or more metals or a metal with non-metal to obtain desirable qualities such as hardness, lightness, and strength is known as alloy. We can see some examples for alloys here: brass, bronze, steel. These are all alloys made from different metals. For example, if you see brass, brass is a alloy of copper and zinc. So when copper and zinc are melted and mixed, they form an alloy called brass. And bronze is an alloy of copper and tin. And just now you have seen steel is an alloy of iron, nickel, chromium, carbon, etc. These all mixed, it forms steel. These all are called alloys. Next, rancidity. It is another type of reaction when food materials were left for long period. Then fats and oils present in the food materials are oxidized and the food will be spoiled. And even their smell and taste also will be changed, isn't it? I think we'll be observing that at homes also this process. When food materials like curd and milk, if they are kept outside for a long time, what happens? The fats and oils present in them, they'll be oxidized and the food will be spoiled. Then their smell and taste also will be changed, isn't it? Yes, this process is called rancidity. The spoilage of food can be prevented by adding certain preservatives like vitamin C, vitamin E, etc. So to avoid ranciding for the food materials, often they add these preservatives like vitamin C, vitamin E, etc. Usually, substances which prevent oxidation are added to food containing fats and oils. Yes, mostly the food containing oils and fats will be spoiled very easily. They will get rancidity. To avoid this rancidity, to prevent this oxidation, generally they add some substances which control this oxidation of these oils and fats. Keeping food in airtight containers helps to slow down the oxidation process. So generally, if we keep these food items containing fat and oil in airtight bags, then we can slow down this oxidation process. Manufacture, for example, the manufacturers of potato chips, they flush the bags of these chips with nitrogen gas to prevent the chips from getting oxidized. Okay, in this way, rancidity can be prevented by adding some substances which can prevent this oxidation of oils and fats containing in the foods. So if this chips packet if it is filled with the flushed with the nitrogen gas, this nitrogen gas reduces the oxidation or prevents the oxidation of food present in the chips. Okay, this is about rancidity. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.